Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. In this lecture video, I'm going to discuss about the chapter 4.6 beam deflection by singularity functions from Shikli Mechanical Engineering Design textbook. Okay, so for those who don't have the textbook, you have the textbook with you because it will be beneficial. What I'm going to discuss with you is an additional things lah. I hope you can. I hope you can benefit more and you can ask your respective professors, okay, about this. Okay. So let us begin. Okay. Singularity functions in beam deflection. What is a singularity function? The purpose of singularity function is to simplify the analysis, simplify the analysis of beams with discontinuous loads, allowing engineers to model deflection accurately even for statistically indeterminate beams. Okay, what is discontinuous load? Okay, imagine you have a beam like my hand here. It will act as a beam, and then I bend my hand here. I bend my finger here. This part is discontinuous. This is the place that uh, the singularity function will be calculated lah, like this. Negative argument ignorance, singularity function disregard term is negative arguments, necessary learning equation, and avoiding complex condition. Condition for beam deflection useful in situation like point loads on beam where deflection profile need compact representation. Okay. So load representation, compact notation, XA enables representation of loads at specific points such as concentration and dissipated loads. Simplified deflection in calculation, integrating function terms provide continuous deflection profile, eliminating need for the multiple equation. An example application in the simply for butter beam with a center point load, singularity function streamline deflection calculation. Okay, so this is the function of singularity function lah. So benefit of security function for indeterminate beams. Okay, beams that you cannot simply calculated, meaning that it's not that straight line beams in beams that have parts and everything. Okay, it is useful for beam with redundant supports by reducing algebraic complexity and making closed form solution possible. It reduces boundary condition requirement, thus allowing structural engineers to calculate deflection profiles with extensive boundary equation and enhance solution precision, which achieves more accurate reflection calculation, aiding in robust structural designs. Okay. And practical example of beam deflection with singularity function, simply supported beam with central loads, a point load at the midpoint result in deflection that can be described using a singularity function equation. Deflection equation. So deflection at any point, which is you can see in the textbook, there are equation properly written. This will simplify the calculation across the entire span. And unified model covers entire beam span with a single equation, removing need for segmented calculation. Okay, there are calculation in the textbook. It is better that you refer to the textbook. Okay, that's all for the video right now. I hope you can get benefit lah from this video. Okay, so we meet you in the next video, inshallah. Thank you very much.